Good afternoon, everyone. I wanted to take some time to go over problem set 3. By now, you've received your scores for problem set 3, and each question I provided the number of points. I was linking each problem to 80 points in total. But I wanted to make sure that we understood precisely what to get out of this and why perhaps you received some points off on your problem set. By and large, I was pretty happy with problem 2. Everyone did a pretty good job of determining if there's any serial correlation problem. The thing to note in problem number 2 is that there is a lag of the dependent variable. And when that happens, the appropriate test isn't the Durbin-Watson test, it's the Durbin-H test. But the Durbin-H test only allows you to check for AR1 processes. So you should still, in addition to using the Durbin-H test, take a look at the Bush-Pagan or Godfrey LM test for higher serial correlation processes, or the lung box test. That's what I was taking a look at. And again, concerning degrading collinearity issues, not only report the VIFs, the condition indices, but also the variance decomposition proportions. And degrading collinearity is defined whenever there's a condition index bigger than 30 and at least 2 or more variance proportions bigger than 0.5. I know Stata uses as a cutoff of 0.3, but I was adhering mostly to the work of Belsley, Koo, and Welch. Pretty happy with the problem 2. I think everyone did well on that. The same for problem 3, but just keep in mind influential observations occur whenever we have our student statistics bigger than 2 in absolute value, or that hat diagonal element is greater than or equal to 2p over n. And in this particular case, with 20 observations and a p of 4, we're looking at the hat diagonal element being bigger than 0.4. And then, of course, applying the least absolute error method, quantile regression to 50th percentile. In problem 4, again, people did pretty well. Leverage points are looking at HII. Again, the appropriate cutoff is 2p over n. Outliers deal with our student statistics bigger than 2. And in order to have an influential data point, you would need to meet the criterion for the hat diagonal element and the R student statistic. Except in this problem, if estimated correctly, there aren't any influential data points, so it's not necessary to use the LAE method. So if we scroll down the page here, looking at additional problems, and again, most people did well in looking at these particular problems. By the way, I should go back and tell you that your professor cannot count. So we have number 1, number 2. I renumbered this number 2, number 3, this number 3 to number 4, that number 4 to number 5. So this would now be number 6. Most people did pretty well here. A is abrupt structural change evident based on the estimated coefficient of the Great Recession. Well, if we didn't have the variable Great Recession in the model, and we knew when the Great Recession occurred, we could have used the Chow test, because you're looking at abrupt structural change. But since we have thrown in that dummy variable corresponding to abrupt structural change, that estimated coefficient turned out to be statistically significant. So that's consistent with what might be done with a Chow test by incorporating a dummy variable. Remember, if we had used the standard Chow test. Here in this case, we had already done that with the Great Recession. Now, in considering the Farley, Hennig, and Maguire test, most people did this correctly. What I wanted to do, we already had a trend variable in the Shabani equation. All I really wanted you to do is to throw in an interaction term with the trend variable and the own price of Shabani, and then to determine whether or not that coefficient was statistically different from 0. Now you can do this one of two ways. You could remove Great Recession and do that, or you can keep Great Recession in and do it that way. And the same thing would be true for C and D in carrying out the cumulative sum and cumulative sum of squares test. So again, most people did pretty well on question 5. On question 6, though, we had a couple of issues. Number one, if you'll look at the setup for this, seasonality, putting in quarterly dummy variables, the real price of natural cheese, which is the price of natural cheese divided by the CPI. We already have given you real per capita disposable income, but just about everybody failed to do this correctly. The real price of wine. Now, the price of wine was given by CPI, seasonally adjusted for wine, but you still need to divide that by CPI to put that on a real basis. And just about everybody, I think, except for one person, failed to do that. Another interesting wrinkle here is instead of using the log of per capita or log of real seasonally adjusted demand enhancing expenditures or advertising expenditures, we use the square root. Now, that makes calculating the marginal effects a little bit different, and then from the marginal effects to get the elasticities. But if you were to carry that out correctly, that's how you would get the short run advertising elasticity for cheese and the long run elasticity, advertising elasticity for cheese. Now the question is, how many lags? And rightly so, I asked you to look at 1 to 4. Depending on the package, you may not be able to do a lag of 1 or 2, depending on how many degrees of freedom are saved with the use of a second degree polynomial with endpoint constraints. And on that note, there were a couple of people who didn't employ the endpoint constraints, and that restricts further the number of parameters that you have to estimate. So if you didn't employ endpoint restrictions, you lost a couple of points on that. Then, depending on what the packages you're using would allow you to do, I only wanted you to try the lag structures of 1 through 4. And on the basis of model selection criteria, AIC and SIC, as well as adjusted R-squared, to come up with the optimal lag. And in my calculation, especially if you did the appropriate lagging of or logging of the real price of wine, the optimal lag was 2. Now, if you got a different optimal lag because you had different way to define the explanatory variables, I really didn't dock you much at all. But then based on that, and in my case, as I said, the optimal lag being 2, you should be able to get that coefficient. But that coefficient on the short run, the contemporaneous effect, is not the advertising elasticity. What you have to do is get the marginal effect and then multiply any marginal effect by the ratio of the explanatory variable to the dependent variable in order to calculate that correctly. Most people did the calculations of the mean lag correctly. If there was some question, you may have lost a point. So by and large, pretty good response for equation 6, but I just wanted to point out a couple of things. Now, in question 7 was a disappointment. Couldn't be more frank. A partial adjustment model essentially is the same specification that we have here, except we're not going to use the square root of the, we're still going to use the square root of the real seasonally adjusted demand enhancing expenditures, but we're not going to deal with any logs. And all we need to do is to append one additional variable. What is that additional variable? That additional variable is the lag of the dependent variable, but only a 1-period lag. Where people lost points, and this question was only worth 6 points anyway, if you did a lag of the dependent variable for 2, 3, and 4, that's not what a partial adjustment model does. And once we get the estimated coefficient associated with that 1-period lag, 1 minus that coefficient gives us the coefficient of adjustment. And it's the coefficient adjustment that allows us to be in a position to calculate the short run and the long run elasticity. So you should have gotten a long run elasticity for the natural price of cheese by taking its estimated coefficient and dividing by 1 minus the coefficient of the lag dependent variable. Similar for the long run income elasticity, the long run cross price elasticity, and in this particular case, after you convert it to the correct marginal effects in the elasticity, you should have been able to get a long run elasticity in similar fashion. And then for advertising, the other thing is to figure out how many periods it would take before you reach the desired level or long run equilibrium level of the dependent variable. And I believe the correct answer was 5 based on the table that we developed whenever we were talking about the partial adjustment model. So my friends, go back and review your notes concerning the partial adjustment model. All you have to do is to add as an additional explanatory variable a 1-period lag, a 1-period lag of the dependent variable. Then on question 8, most people did a pretty good job in modeling this problem, looking for serial correlation problems, and the AR structure turned out to be strange. You needed an AR1, AR3, AR4, and possibly an AR5 or 6 in the model. So everyone, by and large, did that correctly. Now, what you need to do in order to test for the presence of arch effects, you need to first correct for serial correlation, and you have to carry over that serial correlation structure, then test for the presence of arch effects. And we can do that fairly easy, looking at, lags of the squared residuals 1, 2, 3, and 4, and then coming up with the optimal arch model that way. Then in the Garch model, similarly, you've got to carry over the same serial correlation structure, add in 1 arch term and 1 Garch term, and then be in a position to compare the estimated parameters for the various specifications, and then to address question F here, the last question, relying heavily again on AIC and SIC. And it turned out in this particular problem, the Garch 1.1 specification was the proper way to go. So I just wanted to let you know some details about that. If you have questions, by and large, go ahead and let me know what's going on. The other thing is the papers are at my office. I know you've gotten your grades. We need to figure out the best way to get you the papers. I'm not sure how to do that. I'm open to suggestions. I thought about putting the papers on a chair outside my outside the suite of offices there where you could pick them up. Likely that's what I'm going to do, but I don't know the next time I'm actually going to be appearing at my office until perhaps this weekend. So once again, let me know if you have questions, and we'll be able to discuss further. Thank you so much.